The second lesson of this unit is about drawing a line of best fit. So a line of best fit is a line that passes as close as possible to a set of plotted points. Here we have another scatter plot. So remember from the last lesson that this is called a scatter plot. They don't make a perfectly straight line, but they sort of suggest a straight line. They look like they're going in a certain direction. They look like they're going up and to the right. The points are following a trend. So those are some of the words that we've learned from the last unit. So it says this scatter plot shows a trend in the data. The points go up and to the right. As the maximum daily temperature increases, more cones are sold. So I always like to take a second and decide what this graph is actually about. So it does talk about ice cream cone sales. A title is always important on the graph so you can get an idea. Along the bottom, maximum temperature, along the bottom axis here, the horizontal axis, maximum temperature, and the number of cones sold. So that's kind of where you go to get all of your information about a graph. What this is suggesting is that as the temperature increases, so as the temperature increases in this direction, you can ask yourself what is happening to the number of cones sold. So as the maximum temperature increases, the number of cones sold looks like it's also increasing. So when you're asked to find a relationship or state the relationship of the graph, is it increasing, is it decreasing? As one axis increases, as the information for one axis increases, what happens to the information on the other axis? Okay, so there definitely looks to be a strong relationship here. You can imagine on a really hot day, somebody might sell more ice cream cones than when it's cold outside. Okay. One of the questions for this graph would be to ask you to draw a line of best fit. So this is something new. This is maybe a new term you've never heard before. So a line of best fit comes as close as it can to being an average of these points. So for example, a lot of people might count the points. We can suggest drawing a line kind of in this direction, and I'll try and draw a really good one in a second. We might count the number of points above. So there's a point up here, 2, 3, there's 5 above, and 1, 2, 3, 4, 5, 6, 7, 8. That's kind of a good way to estimate if you've gotten your line in the right spot. This line of best fit as well, the line of best fit does not have to go right through 0, 0. Sometimes the line might suggest that it's, going through there. In this case, it does look like if it was 0 degrees outside, it looks like this place would sell 0 ice cream cones. So it's possible that our line does go through 0, 0 this time. Okay, I'll try and use a nice straight line here and see if that'll work. Okay, so I want to draw my line as if it is sort of an average. Okay, and it's probably easier to do this with a pencil and a ruler instead of trying to use the smartboard. Especially isn't great for this, but I can't really ignore all those points up here. Right, I might want to get this line up a little bit higher, something like that. Okay, something that looks about like that might be a good estimate. I didn't want to make it too low. If my line came down, more through these points down here, I didn't really want to ignore some of those really high points up above. So I realized that my line doesn't actually go through all of the points, meaning there's 1, 2, 3, 4, 5 above, and there's more points than that down below, down here. But that's okay. That's okay. If I feel that this is a good average between all the points, it's a good representation of where the line should go, then it's really kind of my decision. Okay, so when you draw a line of best fit, somebody else beside you might draw theirs in a slightly different, it might not be quite as steep or something like that. But again, we're trying to just do an estimate here. This is an estimated line that is an average through all the points. Okay, this line helps us then to determine answers. When we look at question B, estimate the number of cones sold when the maximum temperature is 31 degrees. So if the maximum temperature is 31 degrees, again we decide maximum temperature is there along the bottom axis. If we're at 31 degrees and we follow it up in this direction, we're going to estimate that they might sell about 180 ice cream cones. And I'm making that estimation based on where my line went. Okay, somebody that drew a line that might have been a little bit lower, they might have a slightly lower estimation than I did. But that's not the end of the world. Again, these are just estimates. Question like this on a test, if you said 180, somebody else said 170, I would mark them both right. We're trying to estimate here. If somebody said they would sell 120 cones, if it was 31 degrees, that's when you might get the wrong answer. Okay? We're trying to come as close as we can to an average estimate.